This video is on solid revolution. Here I have the graph y equal to the square root of x, and then here I have the graph y equal to the 0.5x. And then I'm going to revolve this region right here about the line y equal to 0.5x. And so what I'm going to do is I'm going to take this region right here, and then I'm going to rotate it so that the axis of revolution ends up on the y-axis, and then find the volume of the solid of revolution about the y-axis. And so here's the region again that we want to rotate. And so what I want to do here is rotate this region right here so that this axis of revolution ends up on the y-axis. And so what we need to do is figure out what this angle is, and so that we know how much to rotate this line right here. And so notice that the distance from here to here is 2, and then the distance from here to here is 4. And so the tangent of this angle, which is opposite over adjacent, is going to be 4 over 2, which is 2. And so we have a tangent of theta is equal to 2, and so theta will be tangent inverse of 2, which is about 1.107148 radians, or 63.43 degrees. And so that's what we need to do. We need to rotate this region right here 63.43 degrees. And so now I'm going to rotate it 63.43 degrees. So here we at 60, and so we need 63.43. So this is the rotated region that we want. And so the next thing that we need to do is figure out what the parametric equations for this graph are. And so the original graph, this is y equal to the square root of x, and this is y equal to the 0.5x. So for the graph, y equal to the square root of x, the parametric equations are x equal to t and y equal to the square root of t. And so for this graph right here, these are the parametric equations. And so notice that at this point 0, 0, t is 0. And then at this point, which is the point 4, 2. And then t is equal to x, and so t will be 4. And the equations or the formulas that we're going to need to rotate this the graph, this graph right here, 63.43 degrees, these graphs, these formulas right here. And so the x rotated will be cosine of theta, which is this angle right here, times x, and then sine minus y times sine of theta, and then the y rotated will be x times sine theta plus y times cosine of theta. So once again, the x and the y, they are points on the original graph. The x rotated and the y rotated, they are the corresponding points on the rotated graph. But notice here that x is t, and then y is the square root of t. And therefore, these are the parametric equations for this graph. And so now that we have the parametric equations here, then we can rotate it about the y-axis and then get the solid of revolution that we want. And once again, this angle right here, this angle theta, is tangent inverse of 2. And so I'm going to let A be cosine of theta. And then I'm going to let B be sine of theta. And so these are the A value, and this is the B value. Since we know the parametric equations and we know that we're going to revolve it about the y-axis, then we can use these formulas right here. Um, if for the volume of the curve revolved about the x-axis, then it'd be the y square, y of t square times x, the derivative of x of t. And then for the volume of a curve revolved about the y-axis, which is what we have right here, it's going to be the integral from a to b. In this case, it would be from 0 to 4. T is from 0 to 4. And so it would be x of t squared times y prime of t. And recall that at this point, t is 0, and then at this point, t is 4. And so when we revolve it, this point right here, t is 0, and then at this point, t is 4. And again, these are the parametric equations for this graph right here. And then earlier I called A is cosine theta, and then B is sine of theta. And so x of t would be this expression right here. So this will be A of t, A times t, and then minus B times the square root of t, and then squared. And then the derivative of y of t, which is the derivative of this expression right here. And so b, once again, let's call it b, sine of theta, let's call it b. So here we get t times b, or the derivative just b. And then here it would be a times the square root of t. And so it would be a times 1/2 times t to the negative 1/2. And then simplifying a little bit, and we multiply this out, we get a squared t squared minus 2 times ab t to the 3/2, and then plus b squared times t. And then if we go expand this even further and then integrate, this is what it will end up. This is what we will end up with: 32 over 5a to the 3rd plus 40 over 3a squared times b minus 344 over 15 a times b squared plus 8b to the 3rd. And so this is the exact answer, where 8 is cosine of tangent inverse of 2, and b is sine inverse, sine of tangent inverse of 2. And then approximately it's going to be 1.49864. And so in summary, the volume of the solid of revolution that we want is going to have a volume of approximately 1.49864. And that's the end of the video.